So 7.2, this is where we have to find a confident interval. Similar to 7.1, we have to find a confident interval for the population mean, but the population standard deviation is unknown. So this thing here is the population standard deviation is unknown. They will give you the sample standard deviation. So again, that is probably the key item in 7.2 is you only have a sample standard deviation, and we have to adjust, we have to do some item a little bit different for us to find a confident interval. Okay, so looking at this thing here, this is what we did yesterday in terms of we construct a confident interval when we know the population standard deviation, when we know the sigma. And if we do know the sigma and the population standard deviation, all we need to do is find the point estimator plus or minus a critical value, which is the z critical value, times the standard error, which is again sigma divided by square root of n. And again, looking at this thing here, but in realistically, when we do this thing here in the real world, we probably most likely won't have the population standard deviation. And if we don't have a population standard deviation, and if we can only access to our sample standard deviation, what can we do? Well, in terms of this thing here, this is what they have, or this is a t distribution. Sometimes it's called a student t distribution. It's basically because of the group of students, they found this distribution. They found that by doing this item, eventually this item will become like a standard normal bell-shaped curve approximate a normal distribution. Okay, so again, the only thing different is if we have a small sample, we cannot use a z critical value. Rather than now we have to use a t critical value because we are dealing with a t distribution. The t distribution is, as you will see a little bit later, is have a similar property as a normal distribution. It's just that now, in order for us to find a critical value, this is the one thing that we need is we need the degree of freedom. And how do we obtain the degree of freedom? Well, the degree of freedom is very easy to obtain. It's basically one less than the sample size, meaning whatever your n is, the degree of freedom is n minus 1, which is, again, let's take a look at this thing here, which is, as I mentioned, this is what they tell you is a student t distribution is basically is symmetric, very similar to a bell-shaped curve. It's just that they found out that if the data is smaller, when you have a small number of data, then the t distribution is a little bit flatter. It's a little bit in terms of wide spread out. And if you have and contain more data, if you contain more data, the more data you contain, the closer the distribution become a standard normal curve. Meaning basically if we have a lot of data, then this t distribution is actually the standard normal distribution. So again, that's what we have is after they do so many different data analyze, they found that this thing here have the same property, have the same feature as a standard deviation. It's just that if we have a small number of data, then this item will be a little bit flatter, a bit spread out. Okay, so and that's what we have here in terms of different degree of freedom. Okay, so again, now how do we find this critical value? That's the main thing that we have is, again, to find a confident interval, to construct a confident interval, we need to have two things, which is we have to have a point estimator and a margin of error. And to find the margin of error, we need that critical value. And as you can see, the t critical value is very similar to that z critical value. Right, the area, which is the level of confidence, is your area, and 1 minus alpha, which is the alpha, is the leftover item. Right, so again, the area is the level of confidence, and as you can see on the left-hand side of this item, we have a negative t value, and on the right-hand side, we have a positive t value. And as you can see, this is just similar to the z critical value item. Okay, so now looking at this thing here again, in order for you to find a critical value, a T critical value, we have to deal with this item here, which is we have to deal with this table appendix, the appendix T A1, right? Table A1, which is, again, this is the table A1 that I did not mention to you guys yesterday. We use the same table. We're using the same table to find the critical value for a Z critical value. So yesterday, if you look at this thing here on the bottom of this table, is what we using yesterday, which is yesterday, everybody see right here, this is the Z critical value and the confidence level that we have. This is what we used yesterday, which is, again, 80, 90, 95, so on, which is the Z critical value. So in 7.1, if we ask you for a Z critical value, this is the actual Z critical value that you have. And if they ask you for a T critical value, the T critical value is all of this item in here. And as you can see, each of the degree of freedom have a different critical value, because the smaller the degree of freedom, the smaller the data we have, the flatter the table, or not table, the distribution will be. So that's why the value are different depending on your degree of freedom. So there are two things that we want to look in terms of this table here, which is on the bottom is still your level of confidence. If they ask you for 95% confidence level, which is this is 95%, and then depend on your degree of freedom, as you can see on the right hand side here. If you can see on the right hand side here, this is your degree of freedom. So the degree of freedom is 10, 11, and so on and so forth. Each degree of freedom, this is each individual critical value depend on your level of confidence. Okay, so if you look at this thing here, let's take a look at this item here. Again, that's all we're doing is to find a critical value by using that table. So for instance, if they give you this question and they ask you find a critical value, right? Find a T critical value, which is, again, a sample size 10 is drawn from a normal population. So again, normal population bell-shaped curve, right? Find a critical value, a T critical value for a 95% confidence. So how do we find this critical value for a 95% confidence if we have a data in terms of the 10 sample size, right? So if we look at this thing here, if we, and again, I will go in and I will post this, and if you do your homework, they have this chart for you. They have this chart for you in terms of the if you click on the chart. So if we look at this thing here, reminder, well, reminder, if you do this thing here, make sure that in order for you to find a critical value, the first thing you need to have is you need to have a degree of freedom. Reminder that the degree of freedom is not the N. The degree of freedom is the N minus 1, which is the degree of freedom here is 9. Okay, so again, that's the first thing we want to have, or that's the first thing you need is you need the degree of freedom, which is in this case, you need 9. And now we ask ourselves, what is the confidence level, which is in this case, the confidence level is 95. So if you look at this thing here, all you need to do is we go into this item, which is, again, we go into this items, which is, if you look at this thing here, which is 95 is right here, right? This is my 95 column, right? This is the 95% column. And now my degree of freedom is 9, which is, everybody see that, again, this is where they intersect, which is, again, where they intersect, that is my critical value, which is, again, everybody see that, again, the degree of freedom, which is degree of freedom is N minus 1, which is we have 10 data. 10 is your N minus 1 is your 9, which is 9 degree of freedom. And again, because they ask you for a 95%, we go to a 95%, we go up here, which is 2.262. Okay, so again, this is what we have in the sense of to find a degree of freedom and to find a critical value, which is a T critical value. Yesterday, if they ask you to find a Z critical value, then the Z critical value is just right here, which is 1.96. Okay, So again, question with this table here, in terms of using this table to find a critical value. So again, looking at this thing here, as you can see, or as I mentioned earlier, this is what we have, which is a T critical value for a sample size of 10 and the 95% confident, which is 2.262. And similarly, if you ask you this thing here, which is again 98% and a sample size of 19, which is again the first thing we know that we need to find a critical value is we need to find a degree of freedom, and in this case the degree of freedom is 19 minus 1. So make sure, this is the careless mistake a lot of students do, is they go in and they look at the 19. Don't look at the 19. The degree of freedom is the first thing you need to looking for, which is the degree of freedom is 18, and then you're looking for your 98%, right? So again, your 98%, which is looking at this thing here, your 98% as the same as before, your 98% is right here. We go down, or looking at this thing here, my 98% is this column. And again, now what is your degree of freedom? Your degree of freedom is 19 minus 1, which is your degree of freedom is 18, which is, as you can see, this is my critical value. My critical value is 2.552. Everybody see that is your critical value right there, which is again the degree of freedom, which is 19 minus 1, which is 18, and the percentage, the level of confidence is 98, which is, in this case, I can see that the place that the two items intersect, which is 2.552, that will be your degree of freedom. So question here in terms of how to use in this table, how to utilize this table here. Again, your z-score, this is the z-score last time, which is again, your z-score is right here, or your z critical value, that the one that we used yesterday, that's on the bottom. Today, because we deal with a sample standard deviation, we have to use a t critical value, and the t critical value, we need the degree of freedom and we need the percentage, which is your t critical value is this item here. So again, looking at this thing here, as I mentioned, looking at this item, that is my t critical value, which is 2.552. And similarly, looking at this thing here, the last thing we have, which is a sample size of 43 and a critical value, find a critical value for a 90% confident interval. So looking at this thing here, we know that the degree of freedom, which is 43 minus 1 will give me 42. And one thing, ladies and gentlemen, one small item, small obstacle we have is, if you look at this table, we don't have every single value in there. After 40, they jump to by 10, which is 40 jump to 50, 50 to 60, 60 to 80, 80 to 100, and so on and so forth. So what happens if you don't have the value? So the rule is, in order for us to use this table, if the value is not present, we will use 1 unit less than that value. So our value is 42, which is the 42 is not here. So if the 42 is not here, then we will use 1 unit less than that value, which is again, the 1 unit less than that value will be 40, which is again, this will be my critical value, which is 1.684. And again, even though if your degree of freedom is 49, even though your degree of freedom 49, we still use the 40. We still use the unit below, 1 unit less than the actual value, okay? If the value is not present, if the value is present, if any of this number, then that's what you're going to use. If, for instance, you have 75, well, 75, we have to use the 60. I know you say, wait a minute, 75 is closer to the 80. Why are we not using 80? Again, we want to use a smaller unit in terms of the degree of freedom. Okay, so again, that's the idea, or that's the one last item that you need to remember is, if the number is not present, then you have to use 1 below. Okay, so in this case, as you can see, the confidence interval or the critical value is 1.684. That is my critical value for a 42, even though it's 42, but I don't have the 42, so again, I use the 40. Okay, so now looking at this thing here, we see that we can answer this problem, which is 1.684. And again, this is just the same thing that I just mentioned to you guys, that if the number, the degree of freedom is not listed, if the degree of freedom is not listed in that table, then again, if the number is less than 200, we will use one number less than that actual number, the next smaller number on that table. Okay, and if the number is bigger than 200, if your n is bigger than 200, then you have to use the z value. And again, the reason is, this is the idea. The idea is, the more data that you get, right? The idea of this t distribution is, when the data is small, then it's flattened out. It's different from the standard normal curve. And if the data is large, and again, this thing here, if it's larger than 200, then this basically we assume that it's become a standard normal, and that's why we're using the z value. Okay, so again, if the data, as you will see a little bit later, if we have a sample, humongous sample, then it basically become a z distribution. Okay, and that's what all the students, they compute this distribution, and that's what they found. So looking at this thing here, the same assumption we have from this chapter 7.2 is the same as the previous chapter, which is, again, your item have to be random and your data have to be bigger than 30. If it's not bigger than 30, then it has to be approximately normal. Okay, so again, it's just one of the assumptions that we have to take. So let's take a look at this thing here, which is, again, this, as you will see later on in chapter 7.3, this is the same 5 steps that you have to conduct to find the confidence interval, which is similar to yesterday, which is the first thing we need to have is we need to have a point estimator, which is for the population mean. The population mean, the point estimator is the x-bar. And after that, for this thing here, we need to find a critical value. But in order for us to find a critical value, the t critical value, we need to have the degree of freedom first. And once you have the critical value, then you compute your standard error, which is the standard error, as you can see, the sample standard deviation divided by a square root of n. And then again, what do? Which is we need to find a margin of error, which is the margin of error is just a critical value times the standard error. And once you have that, which is, again, now we can construct the confidence interval, which is we take the point estimator, which is the x-bar, minus the margin of error to find a lower limit, and the point estimator plus the margin of error to find your upper limit, which is, in this case, once you have this item here, you have to interpret your item. You have to say, based on this thing here, we know that the population mean is between this range. Okay, so looking at this thing here, let's take a look at our problem, which is, again, one thing is the hardest problem, not hardest problem, but the biggest obstacle I mentioned to you guys last time is, all of this word problem. How do you determine which one is in 7.1 and which one is 7.2, right? So looking at this thing here, this should be a key idea for you to recognize that this item is in 7.2 because we deal with a sample standard deviation. Okay, but again, look at this item here. They tell you that a sample size n equal to 35, which is, again, bigger than 20, that's bigger than 30, have a sample mean of 34.85, and the sample standard deviation. So again, if you see that they mention sample standard deviation, we need to do some adjustment. The adjustment is now, instead of doing the z critical value, we are dealing with a t critical value. And if you recognize that we deal with a t critical value, then we know that we need to have a degree of freedom right? We have the point estimator, we have the n, but again, looking at this thing here, if we do this by hand, we need to have the degree of freedom, which is in this case, the degree of freedom is 34. Make sure it's 34, not 35, okay? And after this, which is again, looking at this thing here, let's take a look at A, which is construct a 98% confidence interval for the population mean here. So looking at this thing here, how do we construct this? Well, we know that we need to have a critical value, which is again 95% confident. Do you agree that 95% confident, which is again 95 is right here, right? This column that we're looking for, 95%. And again, looking at this thing here, do you agree that 34, because 35, because again 35 minus 1 is 34, which is this is my 34 item. And again, 95% confident, which is the T critical value is 2.032. Again, that is how you find your T critical value, which is we need the degree of freedom. And then we need the percentage, which is again 95%. Is it 95 or 98? Okay. Either 2.032 or 2.441. It's depend on 98. So again, 2.441. So again, that's what we do in terms of find the critical value, which is again the sample standard deviation keyword tell you to use in the T distribution. So once we have this thing here, we know that we need to find a standard error, which is the standard error is your standard deviation divided by your standard deviation divided by the square root of n, just like before, which is in this case, everybody see that this is my standard error, which is 3.025652232, right? And again, like I say, I just want to keep as many decimal I can, and until the end, then I will route up to whatever the number I have needed. And after I have a standard error, I need to find a margin of error. Reminder, a margin of error is the critical value, which is in this case 2.441 times the standard error, which is 3.025652232.
I have a question.
Yes.
Where we got the 17.9 from and the standard error?
Right here. 17.9 is the standard deviation. Up here.
Sorry. Okay, got it.
All right.
Those are always the same, Mr. Tran? The standard error and the standard deviation? Are they always the
standard
same?
error? The standard error, yes, is always the standard deviation divided by a square root of n. Yes, that's your standard error. It depends on the problem, so your standard deviation will be different, right? Your standard deviation, your n will be different. It's just basically, it just tell you to take the standard deviation divided by a square root of n. So again, the standard deviation is 19.3 for this problem. Maybe the next problem, 34.2 or something like that. But again, the standard error, yes, the formula for standard error is the standard deviation divided by a square root of n. Yesterday, we deal with a sigma, which is the population standard deviation. Today, we deal with an S, right? Because we deal with a sample standard deviation. Okay. And yes, the margin of error is the same, which is you take a critical value, which is our critical value in this case, because we deal with a sample, we have to deal with a T, which is the T critical value times the standard error, which is this number. So 2.441 times 3.025, right? And then whatever this item is, reminder, this is your step, your margin error step 3. Now we have to construct the confidence interval, which is to construct that. I need to take the point estimator, which is the X bar, minus the margin of error, which is I need to take the 34.85 minus 7.385617098. And then I need to take the same number, 34.85 plus the margin of error, which is again, when you subtract, you have a small endpoint. When you add, you have a bigger endpoint. So again, I add them up, and then at this location, at the final answer, this is where I say, okay, if the connect map asks me for 2 decimal place, I route it to 2 decimal place. If they ask me for 3, I route it to 3, right? So this one here, I just keep it 2. or if they wanted 1 decimal place, you have to give them 1 decimal place. Okay, so given this thing here, this is what my confident interval is between 27, whatever this data is. I don't know what this data is, right? They didn't tell me the story behind this data, but whatever that data is, the population mean will be between 27 and 42. Okay, so again, the idea or the concept of this item is very similar